Let us draw an interesting and important equipment, that is the last chapter, the power system protection equipments. This chapter consists of how to draw plate earthing, pipe earthings, circuit breakers and lightning arresters. In this class, we are going to learn how to draw plate earthing and pipe earthing. As an electrical students, we should know what is the purpose of earthing, what are the factors affecting the earthing resistance, classification of earthing, procedure for pipe earthing and procedure for the plate earthing, and where we are going to use these earthings. Because in drawing point of view, no need to know all things, but as electrical students, we should know, we have to give the importance to earthing. Let us cover this all topics in this class. What do you mean by the earthing? So, direct connection of the non-current carrying parts of electrical equipments such as framework, motor body, earth terminal of third pin, socket, etc. to earth is known as the earthing. That means, if you observe in iron box, the body of the iron box generally made of the fiber. Olden days, so this body also metal parts. Actually, that is not carrying any current, but due to the internal filament fails, mica sheet insulation fails, it may touches the leakage current may comes to the body of the iron box. If it touches that iron box, so while you are doing the iron, you may get the severe shock. For example, you can take our ceiling fan. The blades of three ceiling fan, 3 blades of ceiling fan and rod may not get the electrical shock, but sometimes may get the electrical shock. How? Due to the leakage current. So on examples. Now, so what is the earthing? So earthing is a non-current carrying parts wherever we require it. Then that part should be forcefully, we are going to make it the zero potential with help of the grounding. So in our house, you can see there is a one socket. Here we are going to the third pin, the top one pin, we are going to earth. So that will take care of any our devices. If leakage current comes, it will bypass to the ground. And you can see the motor also. The motor also body, a yoke, you can see that should be at zero potential. So this body and third pin should be connected to the earth pit. So what is the earth pit? You can see here. So this is a one GI pipe or plate placed underground at the depth of nearly 2 to 3 meters depth, and using some material, charcoal and salt. That means it is they are going to maintain the moisture which can absorb the leakage current. So this all third pin and body, so we are going to connect this earth pit. So you know this one. So otherwise what will happen? What is the necessity of this earthing? To ensure the safety of life and the property from the hazards of electric shocks and electric fires sometimes. To ensure the system voltages on healthy lines remains within the reasonable limits under the fault condition, thereby preventing the insulation breakdowns in our power system. You can learn later this one, neutral earthing. To provide the low impedance path to facilitate the satisfactory operation of protective devices under the fault conditions in our substations, just like the relays. To provide an equipment, the equipotential platform on which the electronic equipments can operate. Dear students, you might observe in CP compulsory require the earthing, otherwise motherboard maybe fails, hard disk maybe fails frequently. To provide an alternative path for induced current, minimize the electrical noise in cables. Hence, this is very essential to provide earthing. You can take the one example. What will happen if earthing is not done for a given one device? Let us see. So, the purpose of earthing, you can observe here no earthing takes place here. Okay, so then what will happen? If any leakage current comes, then automatically you may get the electrical shock. So that can be avoided. So if earth is provided for the equipment, so we may not be always cautious about this one. Okay, then you can see here the electrical equipment, the person is touches, the fault current passes through the healthy body, you can see here. Okay, so what will happen? You may get the electrical shock. So the current, leakage current is closed through our person. The person cannot withstand these heavy currents. So dear students, that's why we required earthing. Now we can see it. So here is a not earthed. So current takes a least resistance path to flow to his motherland. Ground always try to flow. If there is situation, same situation, if I earthed, so equipment, electrical equipment here is not earthed. If I earthed, what will happen? You can see here, you can see this is the equipment here, and this equipment I am not earthed here, I earthed here with help of my earth pit. The fault current passes through the earth, you can observe here. So what will happen? So what? There is no path here. So whatever the current comes here, touches, that has to flow through is this path only. But in this case, there is a path to flow here. So here bypassed, the person is escaped. So that is the purpose of earthing, dear students. You are very, very essential. Wherever you are going to the any industry, you insist every equipment should be earthed. Okay, so this is the main important. Man safe and mission saves due to our earthing. What are the factors affecting the earthing? So mainly this, whether you are going to provide earthing. So this earthing may be, so you can see, so how we are going to provide this earth, what are the factors? You can see here earthing, what are the factors? The electricity takes the least path of resistance. You know that low resistance, the current will be more as per the Ohm's law. The earth resistance value of an earth pit depends on solely on the soil resistance at that location, the temperature of the soil and the soil condition, the moisture content in the soil, and size of the earth electrode here used, and the depth of the electrode in the soil. So these are the some factors influence the earth resistance of the system. Okay, so dear students, so you remember these factors. So mainly the moisture is the water through which electrons will try to flow. So you are going to, main aim is to provide the earth at that place. Okay, so these are the main temperature of the soil, and soil condition, moisture content in the soil, size of the earth electrode, depth of the electrode in the soil, and material of the electrode. Generally we can use a GI pipe or copper pipe. Nowadays we are using the chemical piping also, that is the latest one. The quantity of the coal and salt, so latest we are using a bentonite powder, chemical powder. Okay, so these are the some factors you have to remember to maintain the low resistance path on a earth pit. So how we are going to measure this earth resistance? So as electrical students we should know, so some equipments, as usual we are going to use our earth resistance measure. We can observe this earth resistance measure in our laboratory. Okay, so not only this one, so latest we are using, this is the analog one, latest we are using the digital one. You can see this one, and sometimes we can measure with help of the, so you can see this is the latest meter, and to measure the earth resistance. Now we can see the, so probes, 3 rods, so we are going to measure some based on the distance. So we are using this one, and you can see the another earth resistance measures. These all are used to test the how much earth resistance we have to maintain, the earth resistance minimum. Sometimes we can use a clamp meter also useful to measure the earth resistance. Now if you are observing this one, as an electrical student should know what is the value of the earth resistance in our electrical field, at least in major components. What are the major components? So you can take the transformers in power stations, generators. Okay, so let us calculate. So what is the value? You remember the large power stations, for example thermal power station NTPC, hydropower stations Nagarjuna Sagar and Ramagundam Kottagudam power plants. So that total substation, large power station, the earth resistance must be nearly 0.5 ohms, very less resistance should be required. Major substations, so it may be allowed up to the 1 ohms, and smaller substations, so you can see the 33 by 11 kV substations we can use 2 ohms, and in all other cases just like in domestic other equipments somewhere, so we are going to use this at the 5 ohms. Okay, dear students, so you have to remember this is a very important in competitive exams. At the same time, as an electrical student we should know this all things. Now let us, what are the different types of earthing systems? So mainly, so rod earthing, strip earthing, and plate earthing, and pipe earthing, and maintenance free earthings. These are the main different types of earthing systems using in our electrical fields. Let us see at a glance what is a rod earthing, what is a strip earthing, what is a plate earthing, what is a pipe earthing, what is a maintenance free earthing latest. So you can see here. So this is a rod earthing. Here the copper rod is used for the earthing purpose. Okay, so then you can see this is a one practical example of rod earthing, and you can see the strip earthing. Instead of rod we can use the strip. So thickness of the strip, copper strips generally used in ground. Then you can see the strip earthing also. This is practically used in industries, and very famous is a plate earthing. We can use a copper plate also for earthing purpose. This yellow color is the copper plate, 60 centimeters into 60 centimeters, 3 mm thickness copper plate. So we are going to draw this plate earthing today. Okay, so at the same time you can see the charcoal salt filled layer by layer, 15 centimeters. That is the thickness. Okay, so funnel also used for frequent maintenance of the water, pouring the water. At the same time you can see the GA pipe is having the holes. So we are going to learn in details. Next let us come to the pipe earthing. So this is a pipe, GA pipe, generally used for the earthing purpose. And latest we are going to use the last earthing, the maintenance free earthing, that is the chemical earthing. So here chemical rod or gel rod we are using this one. This is a costly one, and here instead of GI wire, copper wire, we have the chemical powder is coated, and as you can see this is otherwise we can use this copper also, and but we are using some powder, that's a bentonite powder generally used as a chemical earthing. Latest we are using this type of the earthings, dear students. These are the some different types of the earthings used in our electrical fields based on the importance given to the protection of our electrical equipments. Now let us see, our aim is to draw the pipe earthing. So you can see here what is the pipe, you can see. So this is a pipe earthing. So you can left side you can see the pipe, so nearly 2 to 3 meters GI pipe. At the top there is a funnel is provided, and the pipe also perforated with the holes, you can see, and depth that below the ground 2 to 3 meters depth is required. Okay, so let us see that what is the how we are going to provide this earthing. So I am going to show you one earth bit, how we are going to draw this one. Okay, so I think required. So okay, let us see the one animation figure for your clarity, how we are going to draw these things. Okay, let us take this one. Now let us draw one figure. Here you can take the ground, below ground. So I am going to take it nearly 2.75 meters depth, nearly 3 meters below the ground level. Okay, so here I am going to take it, first of all I can take the 19 mm rod GI pipe. So that is attached to the 38 into 19 mm. So another socket I am going to provide. Here 13 mm GI pipe which has some holes I am going to use here. So here I am going to 38 mm. Okay, so this is the pipe I am going to use it. Okay, so this pipe, so actually this is the size of the 2.5 meters. Okay, so I am going to use it some break symbol, then I am going to use it up to this one. Okay, so here I am going to provide the some here at least. So this is placed at some 38 into 19 mm, the reducing the socket connected to the 19 mm GI pipe. So here I am going to connect, so this is one socket. From this one I am going to connect this one. Okay, so this is pipe is so where I am going to provide some holes also. This holes 15 centimeters, one hole I am going to create here. Okay, some holes are provided here and easy to flow of waters. Okay, now I am going to use here some area, this area I am going to use, in which I am going to fill the alternative layers of charcoal or coke or salt. I can use it. Okay, so here I am going to use the holes are the 12 mm diameter holes. Dear students, you have to draw that also. Okay, 12 mm diameters, and from this distance at 15 centimeters, and here also the 15 centimeters so width, that I am filling the alternative layers of salt and coke. Okay, so let us this is some charcoal, salt. So let us take this is the coal. So let us take the first salt, then this is a 15 centimeters depth here, and next the 15 centimeters I am going to provide with the help of the salt, rock salt. Okay, rock salt. Next 15 centimeters coal. Okay, this is a coal. This is a coal, you can take this a coal, and next 15 centimeters salt. So this alternate layer you are going to provide these things such a way that you fill total depth of this one. What is the depth? This, what is the height? This is the length. So depth. So you are going to length this here nearly the 2.5 meters, dear students. This is a 2.5 meters depth. So here pipe I used, what is the size of this pipe? Nearly, so 13.8 mm GI pipe, diameter GI pipe I am used with a length of 2.5 meters. Okay, 2.5 meters length I used this GI pipe. Now after that, so it's connected to the 19 mm. Here I connected the 19 mm pipe. Okay, so 19 mm pipe I am going to use up to the my funnel. Okay, so I am going to, this is also very lengthy, so I use for the breaking purpose. Then I am going to connect here. So they are going to the 19 mm pipe here. Okay, then so I am going to connect here my that purpose I am going to connect with the help of the funnel. Okay, so here I am going to provide some funnel here. So water purpose I am going to use it. Okay, so there is another GI nuts also we are used to provide here, and so mesh also provided on which to avoid the entering of the debris, through which I am going to place the water here. Okay, so this is a 19 mm GI pipe. Now, so if it is the, if you observe this one, it is open, so there is a possible to problem. So I am going to provide one concrete arrangement for this purpose. Okay, so I am going to provide one concrete arrangement here. So that may be, so sizes are given here. So based on the concrete, you are going to provide here this is a length, and you are going to provide, and this is the one. So you are going to use, that is the 2.5 centimeters. This is some length, the 15 centimeters, and here is the some length. You are going to take it. So here you are going to get it. You are going to take it, and so you are going to connect here, and you are going to connect this one. Okay, so these are the concrete. So metals you are going to fill this one. So just like it's a protection purpose, mechanical protection purpose. Okay, what is the size? This is a 2.5. Okay, so that we take the 25 centimeters. So 25 centimeters, this place to this place. Okay, now so this place to this place, we are going to take the 15 centimeters, and this gap is the 2 centimeters. So this length from this place to this place we are going to use nearly so 30 centimeters. Okay, so similar dimensions we are going to maintain, and at the same time the width also we are going to maintain, so nearly 12.5 centimeters. Okay, such a way that you are going to maintain the some dimensions, dear students. And the gap, so what is the gap? The ear gap you are going to provide, that is also 7.5 meters. And so here the distance, this is a curve, you can see this is also we are going to provide for the 12.5 depth. Okay, such a way that you are going to make the dimensions, and after that you are going to provide this is a ground. Okay, so this is a ground, so you are going to provide this both side ground, and afterwards I am going to provide the CI cover hinges or something. So I am going to provide on which so protect my this thing. Okay, so now it is this is a earthing, you can see, dear students. Okay, now so this is a physical. Now I am going to connect with my 12.7 mm GI pipe used to connect, taken out the supply. Okay, so from here, so I can take from this one, so I can use the another color. So this is a total arrangement. From this one I am going to take. Okay, so from here I am going to take this my actual GI earth wire. So nearly this earth wire, so from ground to here 60 centimeters depth. From here you can observe here, this from this place to this place the 60 centimeters. Okay, such a way that you are going to provide it. Okay, so this is a 60 centimeters from this place. Okay, so this is a pipe earthing drawing, dear students. Okay, so you can see the animation also. Now take one center line with a dotted, and from both sides the 15 centimeters, either up left and right side, you take the pipe. This is a pipe 38 mm GI pipe. Now connect with 19 mm GI pipe with socket. Now it is the length of up to the funnel. Okay, total the depth of the from ground to the last tip of the our 38 mm GI pipe is nearly 2.75 meters, such a depth. Now you take the funnel here through which, so we are going to pour the water frequently, and so this breaking purpose I used this one. Now the 15 centimeters the either side of this pipe center line I taken here, and I am going to break for the lengthy purpose, and so I filled with the salt 15 centimeters the width, and 15 centimeters the charcoal, and 15 centimeters salt, 15 centimeters charcoal, 15 centimeters salt. So alternate layers of charcoal and salt is filled, total 2.5 meters depth. So this is the total length is 2.5 meters. Now so at the time of the funnel I am going to provide some concrete arrangement, cement concrete protection I am going to provide. So that purpose I am going to rather one cement concrete arrangement, so with the help of my bricks. Now I am going to connect it. So these all are dimensions, dear students. Okay, so depth is 25 centimeters and 7.5 width, and next it is 15 centimeters. So everything is dimensions, dear students. Now so this is the total connections, you can see. Okay, so this is the total concrete, and both sides is connected. This is the ground level and is connected to the ground level. Now I am going to use this is a 12.7 mm GI pipe for the electrical connectivity from my earth rod to my applications, my distribution board, switchboard. Okay, so this is the concrete fill up. So these are the figure you are going to draw, dear students. Okay, so it is very easy, and please try to learn this one. Okay, so very easy to draw this figure. Okay, so let us see the pipe earthing. So here after that you are going to draw this figure in drawing sheet. It should be just like your all dimensions should be in these positions. Okay, so everything you write step by step neatly. Okay, and mention the label as well as the dimensions. Every dimension is available. If any dimension misses, you take appropriately. Okay, so now so what is the procedure for the pipe earthing? So this is your aim, but no need to procedure, but as an electrical student you should know. A GI pipe of 38 mm diameter, 2.5 mm long, 2.5 meters long is placed vertically in a pit. The pipe is tapered at the lower end for easy driving into the soil. You can observe here, and the pipe is surrounded by a pieces of coke or coal and a salt in alternative layers of thickness 15 centimeters nearly. Another pipe of 19 mm dia and 1.25 mm meters length is connected to the 38 mm pipe through a 38 into 19 reducing sockets. At the top, a cement concrete work is made and is provided with a funnel with wire mesh to pour water frequently to maintain the moisture in the system to reduce the earth resistance. The funnel is connected to the 19 mm dia pipe by means of bolts and nuts. Another pipe of 12.5 mm dia is connected to the 19 mm pipe near the wire mesh. The earth wire is carried to at a depth of 60 centimeters through a 12.5 mm pipe. Instead of wire, I use the pipe. The cement concrete work at the top is covered with a iron plate for the periodic opening and checking purpose. So these are the construction, dear students. Okay, so please draw this figure. Okay, after completion of this one, so next we are going to draw another earthing, this is a plate earthing. So dear students, here instead of everything is same, here everything is same, but here I am going to use, because here I used a 2.5 meters depth, but some soils, some places not possible to dig depth side. At that condition, instead of this length, I can use only a small depth. I can use the plate earthing. So instead of GI pipe, length pipe, I can use the contact area increased with help of the 60 centimeters copper plate. So that is the only thing. This is same. So here is the changes. Here place the copper plate only. Everything is similar. Okay. So how the copper plate, you can see here. This is a copper plate. You can see. Okay. This is a copper plate. Generally 60 centimeters and 60 centimeters, 3 mm thickness of copper plate, earth plates is placed here. Now you can see this is a funnel. Okay, this is a pipe for the pouring water. This is a this is a copper plate, and this are alternate layers of coal and salt as well. Okay, now let us draw this also similar. So we can take this one. Okay, so same. Now dear students, in this case the length is enough for just the 2.4 meters is enough from ground level to the tip of the copper plate. Here only 2.4 meters is enough. 1.5 meters as usual arrangements and nearly 90 centimeters so depth. So the plate, which is a 60 centimeters and 60 centimeters, so placed here, and that is placed under the ground. Okay, so you take the center line as usual and take this plate size nearly the 60 centimeters this side. Okay, so 60 centimeters and 60 centimeters. At the same time, this is a 15 centimeters and 15 centimeters. That means the 15, 30 plus 60, totally the height of the plate is 90 centimeters. Okay, so 90 centimeters and 90 centimeters the plate size, copper plate. Okay, so best copper plate and used here, and the copper plate is placed here at a depth of nearly, you can see from this one the top to here, so depth of 1.5 meters here, and this is 90 centimeters depth. That means we are going to place this ground a depth of after 1.5 meters we are going to place our plates. Okay, now after placing our copper plate, then so we are going to connect the same pipe 19 mm GI pipe as usual, and it is connected to our as usual funnel with wire mesh. Okay, so now for the length purpose I am used to some braking arrangement, and here you can take some gap to fill up the charcoal and coke. Okay, so fill the 15 centimeters salt, 15 centimeter coal, 15 centimeters salt, coal, salt, coal, salt, coal, up to nearly 1 meter. So 90 centimeters the copper plate. So you fill up that thing. Okay, so after that we are going to connect the mechanical arrangement, that is the concrete arrangements, just we have seen. Okay, so the connections also 30 centimeters, all dimensions, you know that. Okay, so now close the concrete arrangement and cover the cast iron, cover it for protection purpose and opening purpose. And this is a arrangement. Now I am going to connect here 12 mm GI pipe for earth connection to my switchboard. Okay, so everything is same, dear students, please practice it. Okay, you can see this is a one example, so you can see here. Okay, so GI pipe, water pipe, charcoal, everything is same. So finally we are going to draw this, dear students, with all dimensions. So you are going to maintain, so this is the dimensions and this dimension, everything you are going to draw it. So please, so draw this one, no need to draw these things. Okay, so just you draw this only one, enough, but you have to maintain the dimensions with the ratios. Okay, so dear students, this is the plate earthing. So what is the procedure? So you know the procedure. The copper plate of 60 centimeters and 60 centimeters 3 mm, or sometimes we can use a GI plate also, but the 60 centimeters into 6 mm is used in case of GI pipe or electrode. A pit is dug about 3 meters depth from the ground level, so nearly 2.4 meters, and for the filling that purpose we are going to require that one. The earth plate is buried under the pit with a face vertical. The space around the earth plate is filled with a alternative layers of charcoal and salt. The earth plate is connected to a pipe of 12 mm dia for carrying the GI wire, and another pipe you can see 19 mm. So 19 mm pipe is connected to the plate for carrying the water from the funnel, and a top of 19 mm pipe funnel with a wire mesh is fitted to pour the water here. At the top, a cement concrete work is done to protect from the mechanical damage to our system. Okay, so next, so you use the 12 mm GI pipe, use it for the our output terminal. Okay, so these are the some basics, dear students. Okay, so you have to draw this thing. Now latest, this is idea purpose, chemical earthing. You can see this is the chemical powder, this is electrodes. Okay, this is a bentonite powder generally used. Earth electrodes. This is a maintenance free. In as usual, the plate earthing and pipe earthing, frequently we require to pour the water to maintain the moisture around the earthing, but in this case no need to maintenance, just like batteries. So maintenance batteries and maintainable batteries. Olden days we are using the maintenance batteries. You can observe in lorries and cars every day, nannu gamaninchumu, just like. So here nowadays we are no need to pour the distilled water in batteries. Similarly, in this also no need to pour the water. So the chemical earthing is the latest earthing. Generally we are going to use in our domestic as well as industries. Okay, so now what are this one? Maintenance free. What is the benefit of this one? So chemical rod earthing is used for bentonite based or graphite based compound along with the earthing electrode, a pipe or a rod that helps in improving the soil condition and reducing the soil resistivity. The prime content includes bentonite, graphite or aluminum, silicates and metal powders. So these are maintains a moisture in that area. The procedure of chemical earthing and gel earthing is similar to the pipe earthing, except the use of coal and salt is eliminated in these types of earthing system. The gel rod earthing also another type of the earthing. In this case, so the gel earthing electrode contains a conductor, a crystalline mixture that will protect the electrode in the soil. So this will ensure a highly conductive state for the fault current to pass the earth. Okay, so these are the some benefits, dear students. You can see, so these are the some maintenance batteries. So what are the applications of earthing? So we can use this earthing system in transmission lines to earth towers. We can use this earthing in substations essentially. So what we have seen, this resistance should be less than 0.5 ohms, and in generating stations also we require to maintain the 0.5 ohms. Okay, so now, so you can see the comparison between these types of earthings. A rod earthing we can use in the loose or sandy areas. A strip or wire earthing we can use the rocky areas where it is not possible to depth digging purpose. And pipe earthing can be used for domestic installations. We can use for the DTRs, and we can use for the motors up to 100 HP in our industries, in our laboratories. Where the plate earthing, so for large installations such as transmission towers, substations, generating stations, we preferred this copper plate earthings, dear students. Now in substation there is a different type of the earthing also provided. So mat earthing is the one important. You can see this is a mat earthing. Every structure, the metallic structure should be earthed. So by providing the mat earthing, so what will happen? The parallel path increases, the resistance connected in parallel, then what will overall resistance further reduces. That is required to pass the leakage current. Okay, now you can see the practically, so how the raw earthing takes place in a substation, you can see it. Okay, so this is the mat earthing, dear students. Now at the same time, how the structure is used in the strip earthing. Every structure you can see here, so that is known as the earth strip. Instead of wire they use the strong strip also used for this purpose. At the same time, in substations we are going to use for the lightning purpose, and each and every structure should be earthed. You can observe. Okay, so because due to the high voltage there is a possibility inductions, that induction leakage current, whatever the charge current that we pass to the ground, otherwise the operator may get the electrical shock. Now, so where we are generally you can observe this type of the earthings. So generally we can use, this is the domestic purpose, and it can be used for the multi-store buildings at the top, just like the lightning arresters, and you can use some industrial loads also, common loads, and at the same time it can be used also in communication system also in the towers. So these are the general applications, dear students. Okay, so this is earthing, so regarding to the importance and types, dear students, but our aim is to draw only plate earthing, pipe earthing in our syllabus. Please draw those earthings with given dimensions. Okay, so remaining are the basics for future. Thank you, dear students, for listening. Okay, so please practice it.